Welcome to reInvent 2016, and thank you very much for joining us. My name is Ian McPherson. I'm the Global Marketing Lead for Media and Entertainment here at AWS, and I'm really thankful you joined us today, and I've got a bunch of esteemed colleagues and customers and partners who are going to come up here and share the day with you. So we have got a great program today. I want to talk a little bit about the housekeeping aspects of this first. So this is the first year we have done a pre-registration for events, and I'm sure you guys probably see your calendars full of things you've registered for. We're figuring that out. So between these sessions, unfortunately, it means we have to clear the room and have everybody come back and scan back through, just so we verify that the people who registered are the people who get in. Now, as you can see, there's quite a few seats in the back, so if you haven't registered for other sessions, I fully expect there to be space. But just in terms of protocol, this is how it's going to work. So I would just ask for you to bear with us and have a little patience, because I'm sure that room is going to be very full when financial services lets out at the same time. As you know, we have 4 different sessions we're holding today. The first one is we're having Elemental Technologies up here. They're going to talk about accelerating the transition to broadcast and OTT infrastructure in the cloud. We've got Dustin Enselewski and Khwaja Shams. The second one, we're going to speak with Turner and talk about Turner's cloud-native content supply chain, followed by Discovery Channel and their broadcast workflows and channel origination on AWS. And then finally, we'll have AWS media and entertainment workflows, content creation, streaming, and immersive media. So with that, I'm going to hand it over to Dustin and let him kick things off. Thank you again for joining us.
Thanks, Ian. Okay, so just to give you guys a quick overview of what we're going to be covering today, we're going to really start by focusing on how the cloud can benefit video workflows. So essentially talking about how broadcast and media providers can leverage AWS and elastic resources to process live and on-demand video in the cloud. Then we're going to dive into a little bit more detail about how we can leverage the robust and rich ecosystem of AWS tools to really enable complex VOD processing workflows in actually a very simple and easy to use manner. And then lastly, we're going to talk specifically about how to set up a linear live broadcast grade workflow in AWS. So first, before we kick off into some of the specifics, I want to give those of you who aren't familiar with Elemental a brief introduction of who we are and what we do. Essentially, Elemental is a video processing and delivery company. And what that means is we serve various market segments, primarily folks like pay TV operators, premier broadcasters and content providers. We also serve government and enterprise companies, and essentially we make it very easy for those customers to get premium, high-quality video distributed to every different type of viewing device in the market. And that's everything from a primary screen on a cable, satellite, or telco provider down to set-top boxes like Roku or Apple TV, and ultimately to multi-screen devices like iPads and tablets and smartphones like Apple and Android, et cetera. And we enable those workflows with the same type of high-grade, very high-quality viewing experience that you would expect from a traditional video-on-demand or live broadcast workflow. And that's a pretty unique problem to solve. And what we've done in the last few years is we've actually moved those capabilities to the AWS infrastructure. So we provide all the same processing capabilities in the cloud now that we have on-premise over the last 10 years. And the way we're able to do that is Elemental, at its core, is a software company. Initially, what we did was leverage commodity off-the-shelf hardware and install proprietary software on top of that hardware and distribute that to customers for their VOD processing and live processing requirements. Now, a lot of our customers, though, had pretty unique challenges that the cloud helps them to solve. And so what we did about 4 years ago was take those same software applications that we used to distribute on-premise, and we built a platform for those to be automatically and dynamically scaled on top of AWS. So for live video specifically, What that enables our customers to do is quickly provision more channels. So if you have a broadcaster like somebody doing the Olympics, for example, and they've got a large set of channels that they need for a very short period of time, but they have to be of the same broadcast quality as their traditional linear channels, they can very quickly and easily scale up dynamic resources to power those channels for the Olympics or the World Cup or some other sort of high quality, high scale broadcast event that only persists for a short period of time. Video on demand workflows, on the other hand, really just sort of lend themselves naturally to the cloud. VOD tends to be highly variable in nature with a very different schedule of new content coming in, whether that's because of movie release schedules or seasons ending or seasons needing to be broadcast early. Basically, what you've got is elastic resources that can be provisioned rapidly and dynamically, so you can quickly process high-grade, high-quality content and then scale those resources back down once that workload is complete. And so the challenge this really solves for our customers is what they traditionally had to do was over-provision resources to meet the sort of max capacity that would be required from incoming content. And of course, once that content had been processed, those resources sat there idle a lot of the time. So the cloud really gives our customers the ability to right-size their infrastructure investment. So specifically, I want to talk a little bit about video on demand workflows for OTT in the cloud. Now, we support a lot of different workflows in the cloud, but one of the most common ones is what we're showing on the screen here. And essentially, that's where content has been delivered to S3, and there are a number of different ways customers can upload content to S3, either over a direct connect, or using a snowball service, or even just accelerated transfer into S3, for example. Once that content is in S3, essentially, Elemental provides 3 different types of processing resources to go out and grab that content. The first is one that we'll be talking about specifically here, and that's Elemental Server. Elemental Server is a VOD processing solution that's provisioned within the Elemental Cloud Platform and allows our customers to ingest mezzanine grade content, which is very high quality, large video files, take that content in, convert that content to the many different distribution formats required to deliver to different devices in the market, whether those are set-top boxes or smart televisions, all the way down to smartphones and tablets. And like I said before, what we're doing is we're taking that same high-grade content and converting it to the formats required for the multi-screen distribution, but preserving that same broadcast-grade quality all the way through. And we give our customers a real depth of capability in terms of managing captions and metadata associated with those files to deliver to all the different formats required. And what we do, too, is we enable not only the same types of dynamic outputs or adaptive bitrate outputs to various screen resolutions, but also the different device types required in terms of Apple iOS devices with HLS, Microsoft devices with Smooth, and even Android devices with Dash. So using cloud resources gives our customers the capability to process virtually unlimited content on any schedule. So if a provider like a Netflix or some other similar type of distributor like the one that we'll talk about here in a minute, Cinépolis, all of a sudden onboards a new content provider and they have a huge library of content that needs to be processed very rapidly, they can quickly scale resources to process that workload for the one-time delivery of content, scale those resources down, and then deliver that content to their subscribers. We talked earlier about basically right-sizing infrastructure to scale dynamically as content workflows fluctuate, and then also the ability to create dynamic test environments. And this is really important for our customers because they're dealing with a very rapidly evolving media market where not only do you have new and different types of devices that are flooding the market, but you also have different distribution formats. So we talked a little bit about Dash being sort of a new distribution format. basically what our customers can do in the cloud now very quickly and easily is create sort of duplicative workflows in a test environment, segregate that from their production environment so they can test and ensure the premium delivery of content to devices without disrupting their production workflows. Once that content is verified as playable on those devices, they can quickly and easily roll that back into their production workflow. And then lastly, it's very quick and easy for those customers to update their workflows. And this is not only for new distribution types or new resolutions and formats, but also to provide end users or end consumers with different sorts of value-added playback experiences. And so we'll talk a little bit more later on about live to VOD type capabilities and dynamic ad insertion capabilities, et cetera. Okay, so now I'm going to talk to you a little bit about a customer example that we have from Latin America. The customer was supposed to be with us today and unfortunately had to cancel at the last minute and wasn't able to be out with us. So I'm going to do my best to kind of talk through it. Pardon me if I refer to my notes once or twice during these slides. So I've gone over the slides with him and I can speak to it, but after the session, if you guys have any more questions, I'd be happy to kind of field those for you. So Cinépolis is one of the largest global theater brands in the world, and they have, they're the #4 distributor in terms of the actual number of screens globally, and they're the #2 distributor in terms of the number of attendees that they serve on an annual basis. So they're a really significant force in the theatrical market globally. Recently, Cinépolis launched the Click service, and Cinépolis Click is essentially a companion service that provides a next-generation user experience so that moviegoers can also view content on demand on their multi-screen devices. And the really clever thing about Cinépolis Click is because it is a companion program, Cinépolis is able to leverage the information they have and the loyalty they have from their theaters, apply those same loyalty points to the Click service so that moviegoers can build loyalty points by going to the theater and then apply those loyalty points to download content on demand. And of course, then it's just very cyclical because the more content viewers watch on demand, those points build up back in to go and see the new releases in the theater as well. So it's a very harmonious cycle that they've created, which is a pretty unique workflow. So the way Cinépolis leverages AWS and Elemental is essentially they have distribution partnerships with various content providers who deliver content to them and drop it into buckets on S3. Basically, what they then do is they use Elemental Server to transcode that video content and automatically ingest the content as it's delivered to S3. And they have a whole workflow with various series of quality control checks and various metadata applications. And then ultimately, they process the workflow, or rather they process the content formatted for delivery to all the different multi-screen devices that they serve, and then output that back to S3, and they run some more detailed post-processing applications on top of that content. So Khwaja is going to come up in a little bit and talk to you about some of the advanced post-processing that you can run on the content once it's been converted or transcoded to be delivered to all the various devices. In the case of Cinépolis Click, though, they had a couple of different challenges that they needed to solve for. Essentially, when they launched this companion service, initially, they had a very constrained set of infrastructure to process the content. But very rapidly, they wanted to deliver to a lot of different types of devices, and the success of the service meant that they were growing by 8 to 7 times annually in terms of not only the volume of content that they were processing, but the number of devices that they were delivering to. So ultimately, what they wanted to do is essentially leverage MPEG Dash to deliver to a whole new range of devices in addition to the web application they were providing and the iOS application they were providing. And so in order to do that, what they essentially did was duplicate their workflow that I showed you earlier and created a completely parallel set of resources. They began ingesting the content. They very quickly changed their output settings from iOS to Dash, and we're able to process something like 15,000 titles in just a short period of time of almost 2 weeks. And actually what ended up happening was, and this is what the duplicative workflow looks like. Essentially, it's the same workflow as I showed you before. The only difference is the outputs are dash as opposed to HLS. And because that workflow was processed so rapidly, what they found was the resources scaled so efficiently, they actually had to slow the processing down so the quality control people were able to keep up with the workflow because it was processing that quickly. So where are they going from here? The ability to provision a duplicate workflow is great, especially when you can do so elastically and on demand and then scale those resources down once that new content has been processed and able to be delivered to new device types. But the next step in the Cinépolis workflow is moving to more of a dynamic workflow. And the way that they want to do that, and the way that they've implemented this, is by pairing another elemental application called Delta with the elemental server application. So remember I told you elemental server is designed to transcode and convert premium video into all the different formats required for different device types. Well, Elemental Delta adds a whole new layer of capabilities on top of that, where it can now take these outputs and dynamically convert them to different distribution formats like Dash or HLS or Smooth just in time or dynamically. So what that means is Elemental Server can create those outputs just once, and then Elemental Delta will take those outputs and convert them to the devices that are actually requesting the content dynamically. So in the example that I showed you before, where the customer had taken their workflow and duplicated it and then reprocessed all their content to meet the new device types and the new distribution format. Now what they're able to do is if a new device type or a new distribution format comes out, as soon as that format's requested to Delta, Delta will just automatically repackage and deliver that content. So Elemental Server only has to process the content once, the content only has to be stored once, and then ultimately only the content that is requested is delivered to downstream users. So essentially what they're doing is taking a very scalable and elastic workflow, and now they're making it very efficient. So they're able to reduce their overall costs in terms of processing, but they're also able to reduce their overall costs in terms of storage and ultimately delivery, because they're only delivering the formats that are being requested by users. And you can see the results have been just fantastic for them. Like I said before, they grow by 7 to 8x in terms of request volume every year. They're expanding globally into new markets, and they've just had tremendous success, not only in terms of the click service with the on-demand subscription and transaction model, but also feeding back into their theatrical business. So it's created a very symbiotic and unique business for Cinépolis overall, and they've just appreciated tremendous growth. So just in summary, again, what Cinépolis does, and really it's a great example of what most of our customers can do, and what a lot of premium broadcasters and pay TV providers leverage cloud resources to do, both in terms of AWS services, but also in conjunction with elemental services. And that's to ingest content from S3, which of course is a highly durable and scalable storage solution, automatically convert and transcode that premium content for all the different formats designed to be delivered to different multi-screen devices in the marketplace, dynamically repackage that content and deliver it on a request basis for those contents that actually have required access to it. And then ultimately pair that with a CDN, such as CloudFront in this case, and then deliver the content globally to users. Okay, so I'm going to ask Kawasha to come up now and speak to you a little bit more about some of the specifics about the different AWS tools that can be leveraged to provide a really rich and complex VOD workflow.
All right. Thank you, Dustin. So I'm going to go over one of the workflows that we built with one of our customers. And this is just supposed to be an illustrated example of how you make a complex workflow simpler by using the services that are available to you at, inside of AWS. So if you look at a typical VOD workflow in AWS, as Dustin mentioned, you might have content providers, content owners that have secured licenses to a set of assets. The first part of this is to get those assets over into AWS as swiftly and as cost-effectively as possible. There are multiple venues and avenues for you to take advantage of, starting from Direct Connect, which gives you the ability to get dedicated 1 gigabit or 10 gigabit lines between your peering points in your data centers directly into an AWS data center. Or you can use something like AWS Snowball, which will allow you to put terabytes of information on a device that we ship directly onto your location, and then you can just ship it back to us, and we'll place that data directly onto S3 on your behalf. Or you can use S3 transfer acceleration to get data directly over to S3 yourself, while taking advantage of our multiple points of presence across the world with our content distribution system. Once the data is in AWS, you have to store it in a highly durable, secure, and cost-effective manner. And for that, there's a multitude of very flexible offerings in that realm, starting from S3, which we all know for its durability and low cost and fast retrieval times. But then there's also Glacier for archival storage. And if your workflows require a POSIX-compliant file system, you also have access to things like EFS, which you can mount basically a file system from multiple nodes, and each of those nodes can manipulate it. That, from the storage side, once the data is stored in a durable, secure fashion, now you want to go ahead and start transcoding it and prepare it for consumption by your end viewers. And in the transcoding world, there's a set of options. There are, for the simpler transcodes, we have the Amazon Elastic Transcoder service, which enables you to not have to worry about the resources behind the scenes, not have to worry about AZs, but simply upload jobs for files that are sitting in S3, and then we can just transcode them, and you pay by the minute. For more complex broadcast-specific workflows, there's also Elemental Server and Elemental Live that enable you to transcode these complex jobs inside of Elemental Cloud. Now, once the transcoding is done, you might actually want to do some post-processing. And there are multiple ways for you to do that. If you want to do post-processing, you can do it locally on the Elemental Server nodes, or you can use this multitude of services that are at your disposal to simplify these complex workflows. Things like SNS. So SNS is a notification service. And on Elastic Transcoder, for instance, as your jobs finish, you can get an SNS notification that, hey, this job finished, so you can kick off a new workflow. Or from Elemental Server, you can have your post-processing script perform that SNS notification as well. Similarly, for workflow orchestration, if you have tools like Simple Workflow or SQS, so you can orchestrate these workflows across a variety or a large distributed post-processing fleet, which of course would likely run either on EC2, or you might be running some of these services for the less complex types of workflows, like if you're just doing some quality control or you're just doing some metadata counting, you can use a serverless capability like Lambda. And this is not even all the services that are available, right? This is just a small subset of services that you can use to transcode and then post-process your content for consumption by your end viewers. So on Elemental Server, on a per job basis, you can specify a pre-processing script and a post-processing script. And like I said, you can choose to run these directly on Elemental Server, or you can have these workflows in queue jobs into SNS or SQS so that they can be consumed by a separate post-processing fleet. So the complex workflow that I talked about earlier in the talk that I'll be going over looks something like this, where you get the content, it's sitting in S3, you use Elemental Server to do the transcoding. Once Elemental Server is finished with the transcoding, it enqueues a post-processing job into SQS. Okay? There's a post-processing fleet that is consuming jobs directly from SQS, and it's going to process them and then store the outputs directly back onto S3, where it can be consumed by the end users. When you're building these complex post-processing workflows in the cloud, there's a few interesting patterns that start to emerge. First, you want to be able to decouple the various components that you have. So in this particular example, the customer wanted to decompose the transcoding and post-processing fleets. And there are multiple reasons to do that. One of them is to be able to independently scale the different fleets. Your post-processing workflow might be much more complex or much less complex than your transcode workflow. And you want to have fleets that can be optimized for the specific post-processing workflow. Similarly, you don't want to be paying licensing cost on the post-processing side. You want to be just paying the EC2 instance. So there's cost benefits as well by decoupling. Then, in the cloud, since you have access to a lot of services and resources at your disposal, you want to have visibility. So as you have these thousands of machines that are operating on your behalf, and as you have these thousands of workflows that are coming up, you want to know where each of these workflows are, what their profile looks like, and what is failing and what's passing. And you want to be able to react to it because it becomes a lot more untenable to do that with thousands of machines versus if you just have a single machine that you can just log on to and see what's going on. And then lastly, since you have so much elasticity at your disposal, you want the ability to have fine-grained access control, meaning that since you have so many different components, you want to be able to control in a very fine-grained manner what resources each of these components has access to. So, let's go ahead and take a look at some of the components that were used for this particular customer. So we talked about EC2 and S3. They're very familiar. Simple queuing service. What simple queuing service allows you to do, you can think of it as a very simple queue which a bunch of distributed resources are listening to for jobs. Okay? When one of these distributed resources receives a job, that job is basically marked as invisible on SQS. That node is going to do the job, and then if it finishes, it just goes back to SQS and deletes that job, meaning that it is completed. If for any reason the node is unable to complete the job, or if it takes too long, or the node dies, the job basically after a certain amount of timeout threshold that you configure, the job will just become available for a different node to take on and continue rather than just perpetually failing. And this very simple primitive enables you to build resilience in your distributed post-processing workflow, meaning that if nodes are failing, it's okay because somebody else will just pick up the job once that node goes away or if that node goes away. So if you look at what SQS looks like when you go and configure a queue, there's a bunch of options that you get to see. Things like the default visibility timeout. So even though you can specify a timeout for every job, you can also just have a default timeout for your entire queue. There's a maximum retention period, and all that retention period is if you have put in a set of jobs in SQS but nobody's listening for this many days or minutes or hours, you can just constantly clean up that queue. Maximum message size. So if you want to make your downstream contributors into the queue, if you want to limit the size of the message that they want to put in, you can limit that to a particular size if you want to for cost-saving purposes. The delivery delay, that's simply saying, I don't want to process the job right after it's been in queued. I want to wait at least n units of time before I start processing it. And there's a couple other options at the bottom, which we'll get to in a second. But essentially, once you have created a queue, you get the name of the queue, the URL with which you can post to the queue, as well as an Amazon resource name, which you can use to control that queue's access policies. And then you have this notion of redrive policies. So if you've got thousands or millions of workflows, eventually some of them are going to fail. Some of them might fail because the nodes that particular job just got unlucky and kept landing on nodes that kept failing. Other reasons could be that it's working with a bad input, or there's some misconfiguration in the scripts. And when you have lots of machines, you want the ability to be able to hone in on exactly what's failing and quickly resolve it. So the redrive policy What this allows you to do in SQS is if a message has been received by a set of nodes more than n number of times and has failed every single one of those times, just put them in what's called a dead letter queue. Now, this dead letter queue is a small collection, hopefully a small subset of your workflows that your post-processing fleet is just having a hard time making progress on. You can have a human in the loop who is just focused on only the dead letter queue so that they can be processing and looking at, well, what's going wrong and quickly resolving. Or you can have a separate script or a separate fleet that is just looking at failed nodes and doing aggregations and so forth. So in this particular case, the job schema that we picked looked something like this. And if that looks like gibberish, it may be, but it's basically just a regular expression that is saying, I want you to give me S3, the name of a bucket in S3, and then the path to the object that you have transcoded. And then a name of a script that you want me to run. And that script must be in my, in a very specific directory so that you can't do things like ... and whatnot. So an example of that would look something like this. S3:// my bucket test file 3.mov, and then a particular script. Now, a lot of you may find this to be a little too detailed, but I promise that even if you haven't touched an IDE in your life, you can still understand the workflow here, even though it's in a pretty verbose language. So first and foremost, you go to SQS and you say, give me the next message. And that, it's a couple of lines of code. You're just going and saying, give me the next message. If SQS doesn't have anything, I'll just keep retrying every n units of time. Once I have the message, I want to parse it. And once I have parsed it, I'm just going to make a temporary file where I am going to, which I'm going to use to download, post-process, upload, and then delete at the end. But essentially, that temporary file, I just call download. So I download the file directly from S3 onto the local file system, which with the AWS S3 SDK is also a couple of lines of code. And then you just execute the command. So after you have downloaded, run your post-processing script, you can then simply upload this back to S3, again with a couple of lines of code. And now that you have downloaded, post-processed, uploaded, you can go back to SQS and say, hey, I am done with this job. I actually finished. And then last but not least, in terms of visibility, you want to be able to provide some metrics around what is it that, how long each of the different components of the workflow took. And if you look at this, it's pretty simple. What kind of metrics would you put on here? You would put metrics like when I'm downloading the file, here's how long it took me to download the file. Or here's the bandwidth that I was able to get between S3 and EC2. And same thing for executing the command. Here's how long it took me to process the command. And here's how long it took me to upload. And the reason why these types of metrics are important is with CloudWatch dashboards, you can actually have dashboards which display these metrics on a graph. And you can set up alarms that say, OK, if any one of my nodes is EC2 instances is not able to upload to S3 at a particular rate, I can simply send myself a text message and start looking into it because it might be a misconfigured node, or maybe I have too many parallel workers. Anything or it might just be a node that's having a bad day for any reason. But the point of the matter is that if your workflows are slowing down, you want the ultimate visibility so you can root cause very, very quickly. And these types of metrics are quite a boon when it comes to being able to run in lots of large-scale distributed processing fleets. So we talked about orchestration. We talked about the separate fleets. Now let's talk a little bit about how do you make this more secure. So AWS Identity and Access Management, IAM, enables you to get very complex access control policies that you can specify in a fairly simple manner, but it allows you to really constrain the the access that each node in your system might have. So for instance, you can get as specific as, I want this particular IAM role or user to be able to only delete an object or object version, like very specific verbs on very specific services, on very specific buckets, or on very specific resources, right? And this is what you want to do. You want to make sure that each component in your system has access to nothing more than what really absolutely needs. So in this case, we had this post-processing worker had access to S3 on that very specific bucket, the ability to download, put, delete messages from SQS, and to be able to put metrics on CloudWatch. That's it. On the Elemental server side, the post-processing worker, all it really needs is the ability to send messages to SQS. It doesn't even need the ability to read those messages. Just needs the ability to send the messages to that very specific queue. And you can do that with IAM, with the access control policies. And then lastly, now that you've created all these users and the ability to give them access to exactly what they need, you don't want to be managing credentials across thousands of machines. You don't want to be, every time you rotate and having to go through and embedding brand new credentials into those machines, which would be a security nightmare anyway, because you don't actually want those machines to have your EC2 credentials or your IAM credentials baked in them. So what EC2 workers allow you to do is, once you have an IAM policy configured for a particular role, you can launch EC2 instances that are provisioned in that role, and they have access to everything that that role has without you ever having to introduce the IAM credentials. And those credentials will automatically rotate. They will and the AWS SDKs will automatically use the latest credentials, latest temporary credentials that it will get in real time based on which EC2 instance it's a part of. So all in all, it's a fairly agile and complex type of workflow that we were able to stitch together very quickly with a few lines of code, where we had a very traditional post-processing workflow that didn't really work with S3, but we were able to wrap that around with a few lines of code to download the file, perform it locally, and then upload it back. And then we were able to disseminate this workflow across lots of machines at the same time. And we were able to do that in a cost-effective, resilient manner while enabling the customer to maintain the same post-processing workflows that they always had. Now, all of these services that we just talked about are available for you to use for your VOD workflows as well as your live workflows. And while they will work just as well with live workflows, live comes with a different set of challenges. And Dustin will talk a little bit more about those live-specific challenges.
Next question. Okay, so let's switch gears a little bit here. Like Kwaj just said, we really took a deep dive there on VOD-specific challenges. And while similar, live is definitely unique compared to VOD. In particular, with live, of course, we're dealing with channels or events as opposed to individual assets. And so stability and reliability are paramount in a live linear workflow, whereas a VOD job can simply be retried if a node fails or if the job itself fails. It can be resubmitted, picked up by different resources, et cetera. So live doesn't have that same type of flexibility. With live, you also have requirements now increasingly as the market evolves and develops to deliver advanced features ubiquitously across all platforms. So more and more what viewers see on their television screen from a linear broadcast, they expect to have on their iOS devices, their tablets, and their computers, et cetera. And then lastly, all of this has to be highly available. So customers have to, or come to expect the same level of reliability on their linear viewing experience with an OTT device or a multi-screen device as they do on their primary television from their cable or satellite provider. Okay, so let's talk a little bit about best practices for live streaming, live multi-screen streaming. So in particular, what we want to look at is what types of content can you deliver to the cloud. And especially when we talk about the type of content that's delivered to the cloud, what we really want to look at is, has the content already been processed somehow? Or is the content sort of pre-processed and going to be delivered in a very high bandwidth fashion with a single mezzanine stream as opposed to a set of pre-processed multi-screen outputs? And then we want to look at how to deliver that content to the cloud. Now, this is one of those areas where live is very unique relative to VOD, because the way you deliver a live stream to the cloud, of course, is very different than the way you deliver a movie file. So, we talked about the ability to send a file to S3, for example, or to upload a file with a Snowball device or accelerated S3 transfer. You can't do that with live. And then we want to talk about effectively how to process live content once you do get it to the cloud, which of course is variable based on the type of content that you receive. And then lastly, how you deliver that content downstream to end users. So basically, what we're going to look at is effectively, once the content's been processed and once the content's been formatted for delivery to different distribution device types, then how do we actually send it across the world to those various consumers who wish to review that content? Okay, so a couple of different options. Really what we see are one of two use cases for live ingest into the cloud. And essentially the first and probably the most common is what we call single bitrate streaming. And that's where you have a very high quality source of video content that's being fed to the cloud either over a direct connect or even over the open internet, and then is ingested into encoding and transcoding resources for processing. Now, this is a common type of workflow where you have either event production, where you've got equipment on site at a venue or some sporting stadium somewhere around the world. You've got high quality camera feeds coming into a production truck, and then you've got that production truck sending a single high quality bitrate stream of content up to the cloud for subsequent downstream processing. Now, another fairly common workflow that we still see a lot of is where customers already have invested relatively heavily in their on-premise infrastructure, so they have a lot of video encoding and processing resources. And they want to now start to add value-added services on top of the experience that they're already providing to their customers. So they want to be able to do things like enable customers to have a live to VOD experience where a customer can rewind a live stream or start over that stream if they tune in the middle of the program, or even immediately have that stream available on demand once the program airs. And so commonly what customers will do is they'll take their on-premise encoders that are already creating adaptive bitrate outputs for delivery to multiple device types, and they'll simply redirect those outputs from distribution resources into the cloud for dynamic packaging. And we talked about elemental delta a little bit before. Now, we talked about delta in the VOD use case, but the application for live is really not only to provide that dynamic packaging that we talked about, but also that live to VOD experience. So you can take those outputs which have already been processed for all the different bit rates and resolutions required by different devices, and now you can start to really dynamically add value-added services on top of those outputs. So you can provide those live to VOD experiences. And here's where you can also start to do things like customize outputs for dynamic advertising or advanced advertising capabilities, as well as some more sophisticated filters that I'll talk about a little bit later. So what are the different types of formats that are used to deliver live content to the cloud? There are really three primary protocols that we use to deliver content to the cloud. The first is RTMP. And RTMP is kind of the age-old real-time protocol that a lot of customers have access to from a lot of different types of contribution sources. So these can be Adobe Media Servers, they can be Wirecast applications, even some cameras that can produce RTMP outputs. But it's a very low latency, live linear delivery protocol that's able to get content, live content into the cloud or into a remote location very rapidly. What we're starting to see more of, though, is actually content being delivered to the cloud using HLS. So HLS is a fragmented output type that is commonly used for distribution or delivery to downstream CDNs, content delivery or content distribution networks. But we're starting to see more customers use HLS as an ingest protocol, too. Now, the reason is because since the content's already been fragmented, technically this is actually a file-based input type, and that makes it very resilient. So there are a lot of sorts of retries that are capable, and it also enables a pull model. So instead of having to push content, encoding and transcoding resources in the cloud can actually reach out and pull that content, and they can do so in a very resilient manner. So it's very quick and easy for a customer to set up resiliency models where multiple processing resources are pulling for the same content, but only a primary resource is actually processing and delivering that content. If that primary resource fails, then a backup resource is automatically provisioned online and begins pulling that same content. So customers don't have to redirect their stream from one IP address to a different IP address, or they don't even necessarily have to send duplicate streams or redundant streams for high availability. HLS also has a very rich metadata capability, so you can provide a lot of audio files and caption files as well. And then lastly, RTP or RTP with forward error correction. So RTP is another real-time protocol that is very robust and very low latency. So with HLS, because it is a fragmented or segmented input protocol, essentially what you have is a slight bit of delay in terms of segmenting and delivering those segments to the cloud. With RTP, especially with forward error correction, you do get a little bit of that latency because it is correcting for packet loss and things like that, but it is a very low latency streaming protocol, but also compared to RTMP has a very rich metadata capability. So if you just look at the different types of use cases summarized real quickly, there are different times when you'd want to use one input protocol over another. So in the case of RTMP, if latency is one of your primary concerns, RTMP is really fantastic for that, RTP as well, and then just slightly less RTP with forward error correction. HLS is probably going to be your last choice if latency is your primary consideration. In terms of reliability, all of these protocols are fairly robust and fairly reliable. Probably the most reliable is RTP with forward error correction at the expense or at the trade-off of some latency like we talked about. In terms of capabilities, when you talk about metadata like captions and audio files, language tracks, etc., HLS is very robust, but RTP, being a broadcast format, is really the most robust. So if your key consideration is latency in conjunction with capabilities, then RTP is probably going to be your best bet. So let's talk about content processing a little bit in the cloud. So typically what we get from various providers or various content owners wanting to use the cloud's elastic resources for live processing is content that's either coming in, like I said, from a venue or even from a broadcast facility. And sometimes the reason they'll be delivering content from a broadcast facility is because that facility will simply be at capacity. So they want to be able to add more channels, but they don't necessarily have the physical space to add more processing infrastructure. So they'll go ahead and just send that content to the cloud, and they can quickly and easily scale up more channels in the cloud. They can take that content in, whether it's pre-encoded, or they can take that content in, whether it hasn't been encoded, and actually perform all the encoding and transcoding operations in the cloud. So let's look at the encoding bit specifically. So when you look at an Elemental Live profile, Elemental Live is the Elemental Live video encoding and processing solution, which takes a live input in similar to Elemental Server and transcodes that to all the different output types required for downstream delivery. So it's very easy to essentially ingest video in a highly reliable, highly redundant way. configure that video for delivery to downstream multi-screen devices, quickly and easily define your encoding parameters and settings, and then lastly, specify the exact types of devices that you want to target. Once that content's been encoded, you can then hand that content off to Elemental Delta for dynamic packaging. Now, what Delta provides you the capability to do is ingest that content and only process the content once, so you reduce your processing costs. Once that content's handed off to Delta, then you can start to overlay some really advanced filters to highly specify how and when you distribute content. So for example, you can filter content by device type. So if you have 4K or even 1080p HD resolution outputs, you might not want to send those to an iPhone, for example. You're going to waste a lot of downstream delivery bandwidth by sending that content to an iPhone. But that iPhone viewer is not going to be able to discern, a 4K quality or even a 1080p quality from, say, a 780p. So you can really start to save your downstream delivery costs by getting very specific on the types of outputs that you're sending to different devices. You can also start to overlay customization where you are actually targeting different device types for different types of advertising, for example. And then ultimately, you're reducing your storage costs, especially when you're overlaying live to VOD capabilities like we were talking about earlier. So, of course, with live to VOD, if you're going to take a live stream and capture that live stream for playback on demand later, you've got to store that content. Now, in a traditional video infrastructure and delivery workflow, what a user would have to do is store every different type of format or a copy of the content in every different type of format that they ultimately wanted to deliver downstream. By using dynamic packaging, though, what you can do is store that content just once and then only process that to the type of devices or the types of formats that are requested from downstream users. So for example, if a Smooth enabled or Microsoft Smooth enabled device never requests that content, then the content will never be processed and packaged in that Smooth format. It might only be processed and delivered to, say, HLS for iOS devices. And so ultimately, what our customers are able to do is deliver a very compelling, very rich media experience to all their downstream users. And they're able to add value-added services in a highly reliable, highly redundant fashion. And then once that content has been processed and packaged, it can be delivered to, like I said, a CDN like CloudFront, which is a content distribution network, or it can even be delivered to third screen or multi-CDNs for high availability. So customers have the capability not only to leverage the AWS CDN offering, but also CDN offerings from third parties as well to really provide the most robust experience for the users and ensure high quality delivery to their users regardless of where in the world those users are requesting content from. And then also, we talked about the ability to add live to VOD capabilities such as pausing and restarting TV, rewinding live television, and even starting over or catching up that content. Okay, so that's about all that we had for you today. We talked about how we're enabling customers to migrate broadcast workflows to the cloud. Some of the more compelling reasons for our customers are looking to migrate those workflows is to really take advantage of some of the traditional benefits that AWS provides in terms of the agility, the ability to quickly and easily add new features and new capabilities for downstream users, the ability to dynamically and rapidly scale elastic resources up and down to either address peaks in viewing requirements or workloads, but also to add new linear channels as well. And then lastly, to provide very robust and reliable solutions that are highly fault tolerant and highly available, so end viewers never experience a disruption in service. So we have a few more sessions today where we're going to talk about 24/7 live streaming in the cloud specifically, as well as live linear channel playout and on-demand transcoding. So I think we have just a few minutes to field a couple of questions. So Ian's going to ask the audience for questions. Thank you.
Great. Thank you, guys. Excellent content there.